Hi, I hope you are doing well. Well, right now we're gonna try this problem. It's just a random problem that I just decided to attack. It's called sums of cubes and squares of sums. So let's see the statement. Given the positive integers from 1 through n, can you first compute twice the sum of the cubes of those numbers? 2. Subtract the square of the sum of those numbers. And 3. Divide that result by n divided by 2. And we have an example here for n equals 3. We might compute the result like this. And yeah, we have this example, which the answer is 24. Yes, you probably can do all of this, but be careful on this problem, as n may be somewhat large, and I am expecting to see the correct result, not just an approximate value. Remember, there are always different ways one may solve a problem. And I point out the project the, the Project Euler reference because Project Euler problem 6 is what made me think of this problem, and because the test cases will push the limits of what you can do if you are not careful. So let's see what are exactly those test cases. Maybe we can work around that. Test 1 is for n1, okay. Test 2 is for n2, 3, 5, 10, 123. This is actually quite large. 31, 314, 3141. Oh my god. Okay. 31,000. Okay. Okay again. Oh my god. How can we make this, dude? This is not easy. This is actually not easy because of this. And yeah, 1, 2, 3, 4, 5, 6. And the answer is 3, 6, 9, 12, 15. Hmm. This seems like a very hard problem. Let's see. So our first approach will be doing the classical way. So we're gonna make for I equals 1 to n. Before that we need sum. So we're gonna sum over this. For I equals 1 to n, sum equals sum plus I square, sorry, cube. Done. We need something else? I guess not. Remember that we can get this by just using a formula. Case equal 1 times n times n plus 1 over 2. So this is for the formula of the sum of consecutive numbers. Now we need to square this. Mhm. So now k is equal to k times k, and yeah, we get it. And also we're gonna make sum equals sum times 2. And the answer, which is y, is gonna be this, sorry, this. So sum minus this, which is k in this case, and we have to divide it over n over 2. And this should be our answer. Let's see how this works. If not, we have to do something else. Okay, so this works for the first 9 tests, and we can see that doesn't work for the other ones because probably they are too big. The numbers are too big and we cannot make it work. As you can see, it can work with smaller numbers, and now we have to think how to make this. And yeah, as we can see, there is actually a formula that I didn't remember and maybe I didn't even know. So yeah, there is a formula to get the sum of consecutive cubes of these numbers. So from 1 to n, we can use the formula. Yeah, we're gonna plot this instead of using the most used way, that is just getting a 4. So as we can see, we just change the way we approach this and just use a direct formula, and now it should be easier. Let's see how this works. And yes, we get two more tests correct. And on the other cases, we didn't get anything. So now we have to think what's happening. So yeah, I just try to make it in just one line if that could happen. And it seems that it's the same case. So something else is happening and it's fundamental. Okay, so I just went to MATLAB here and try to show what's happening. And I first try to work with this example that was failing. As you can see, there is a 1 here, meaning that even though we just need an answer that is um, without decimals, it is rounded just at the end of the decimal. So it should be something like the correct answer, this one, point something else like point 0.6, point 0.7, and when we are getting the answer, it is rounded to 1. And the answer or the fix to that is just adding a floor to get a just a natural number answer. This way we were able to pass the test number 12, and now we need to find what's happening with this one. Okay, so I just noticed that if I use floor, then I get a weird answer here. So probably it's ending here and then it's like point 0.4 or point 0.3 when the answer is actually 20. Um, that could be fixed because this is not floor, it's actually round, the answer that we should working with. And in this case it's working. Let's show, or let me see if this can be the way we should approach. Yes, so it actually was using formulas to not lose too much time, and then using round because that part of the statement of the problem was key. And yeah, that's the way we make this problem. Actually, it was quite interesting because there are ways that we can use go through big numbers with just formulas. That's why formulas are very good. We could go through 10,000, this number of six digits, and even this one, which was the biggest one of all of them. So yeah, working with a formula, and yeah, that's it. Thank you.